So guys, welcome to a new free tutorial by JangaFX. It is time to talk again about LiquiGen from JangaFX. Finally, they released the new alpha version. This one is the 0.3 and we have a lot of new stuff. We have bug fixes, we have a new solver for the fluid, for the liquid, and we have also finally the Whitewater. So we like to introduce you to how to use it, how to start playing with Whitewater, and then we are going to split this tutorial in two parts. So this week we will talk about the fluid and we'll talk about the Whitewater, and next week we'll see how to export everything in other software like Unreal and others like maybe Blender, 3ds Max, etc, etc. So we can create a new project. Finally, as you see, we have the basic project. We have essentially to tweak it, so we don't need this collider. So for the moment we are going to set to off the collider. We are going to remove this one, and we say that this one is in the middle, so 0, 0, and the altitude is okay, it's not a problem. The emission is not continuous, but it is a filling. And if we try to press R and then we press the space bar, you see that we have the stuff falling down. But we don't want to falls down. And another problem is the lifetime, because you see that the particles are going to die and we don't need it. So you can remove this one, add lifetime to particles, so we don't need to have the lifetime. Applying reset, and in this way they are going to live forever, okay? By the way, another thing we need to do is to remove the force constant, and essentially it's the gravity, so we can just remove it. In this way, if we try to press, you see that we have just this kind of stuff. You see, it's reset, and now everything is stable. Let's go near the sphere. We can start playing with the scene in a better way. So the first thing I'm trying to do is to have for the skybox an HDR map. I can use something from my list. By the way, you can use whatever you like. You can open something from your HD and stuff like that, and set to off the ground, so we have just the sphere, you see. Then what we have to do, we have to add some forces to have a better simulation here, because it's going to happen nothing for the moment. And we can, for example, let's go to create a force, and we say that we go to have a line, for example, and this force can be able to push up or down or to make a twist. So let's press this one, and you see if we go to have the twist, you see that the particles are twisting, okay? By the way, we need a low force, so let's try with 0.1, and you see that we have this kind of vortex, okay? By the way, let's go to create a mask force, so we can use a primitive, and this one can be, let's say, a cylinder, and it needs to be bigger, so it can go, oh sorry, it can go up, press R to stay here, and let's say that this one is able to go up to cover the sphere. So let's maybe do something like 8 meters, and we do it a little bit bigger, and we go to have also a little bit fall off, so maybe let's go for 0.5, and then if we go to play, you see that we have this force just in this area. So two things. One is that we can go lower with a mask fall off, let's say 0.05, and the twist here can be maybe lower, so R and then press, and you see that the force is acting just in this area, but again is too much. So let's go to make this one smaller and this one lower, maybe to 15. Press R, and then you see that we have just a small twisting over there. Okay, press R again, and then let's go to add, for example, turbulence. And remember that the forces are linked to the scaling voxels, so maybe it would be good to start playing with a lower scale here, so 0.09, apply and reset. Okay, you see that this one is going to splash and destroy everything. By the way, let's go to change also a little bit the absorption, so that is going to work in a better way, and maybe a little bit of roughness. Let's go back here and let's say that the scale is big. Maybe let's try with 50 and press, and you see that it's distorting in a really big way. Let's try with 25. Okay, it is better, but obviously it's really too much. So let's go with a low amplitude. So you see that we have just a small distortion. Okay, we can have a little bit of drag. In this way we are slowing down the forces because we have a little bit of drag. Let's try with maybe 2R. Let's try with a higher value. Okay, let's go back to the turbulence, and let's say that this one has 2 octaves, so more details. And about the turbulence, let's go lower, and let's say that we have for the moment an animation speed, so you see that the waves are moving. So you see that the distortion is animated. I like to have the collision with the sphere. By the way, the sphere needs to be a little bit smaller. So let's go to copy the emitter, and we go to add it there, and let's say that this one is maybe 2.4 for the moment, and we have the collision. So now we should have a collision. By the way, you see that now it is working in a better way because the fluid is moving over the surface here. We can go a little bit lower to have more space, and we have also the filling. So I'm going to create also a drain to remove the particles inside using the same sphere. So this one is draining the particles, and it is also acting as a collision. Okay, so you see that something is starting to work in a nicer way. Okay, press R, and let's say that we can call it liquid sphere free V001. Okay, I like to scale down a little bit more this one, let's say 2.2. And then I like to have a force that is based on the sphere to make an attraction of the fluid. So we go to create a new one, and let's call force shape. And we're going to use the same, and we say that maybe we have an attraction of 1.3. Then press R and play, and you see that now the fluid is moving, but it is still trying to stay over the surface, so it is not going everywhere. Okay, so that's really nice because it is moving over our sphere. Let's go over the force and say that we don't like to see the forces, so we are removing this red color over it. Press R, and then we can save game. Okay, let's go lower with the voxel resolution, We're going to use actually, you see, 12 gigabytes of RAM, and we don't need for the moment to have so much voxel because we are using just 2%. So let's go lower to 16. We are going to have a lot of memory back, and you see that we have still a lot of space to play with the stuff. So press spacebar, and you see that it's moving in this way. We have more details than before. I like to start playing with some with the turbulence. So the first one, this one can be bigger. So let's go for 60, but obviously we have to take care about the voxel space here, and we go to have just an higher speed here. So if we press R, and you see that we have this kind of really big scale, but obviously later it will be a little bit smaller. So let's get into simulation. If we like to have a more stable stuff here, we can, for example, use, you see, a higher ISO value about the meshing, and if we like, you can have a higher smooth. We can decide how much, and if we like, we can activate the generate as DF on smoothing. Okay, so it is nice to have it to make some correction to the mesh. Then if we try to simulate, you see that the fluid is not bad. It seems stable enough. Okay, so let's go to create another turbulence. And this one will be a little bit bigger, different, you know, because we are going to have a different scaling for this one and some different parameters. So this one will be bigger, but we'll see the effects using a higher scale about the voxels. So let's say that this one, the amplitude is 0.15, and about the animation, again, we go for a really fast animation, 5. Reset and play, and you see that we have a really high energy force over our sphere. So Control S to save. So it is time to go low with the scaling there. Let's try with 0.25. Apply, and we need more particles. You see, because the quality is higher, so we need for sure more particles. We are using all particles. So let's try with 16. It seems working. We can see later if we need more. By the way, let's press spacebar. Obviously, it is going slower about the simulation. The iteration is still enough. You see that we have 16 iteration and we have maximum 75 iteration. So we don't need more iteration for the moment. So you see that it's starting to break and starting to create this kind of strange simulation. Okay, Control S. So let's go to tweak a little bit as one, and let's remove the distance. Now let's go to add a little bit of fall off directly, and what about the I like maybe to have a little bit more twisting, but we can check it. So let's press the simulation and let's try to remove the drag, because now it is more stable, so we don't need any more so much drag. Okay, you see that it's starting to move over it in a more interesting way. We have the waves that are simulated. Let's go in the line and let's see what happens if we have a really high value. It is starting to twist with a really high energy, so maybe it's too much. So let's go here and let's say maybe 0.15 gain, and then back, Control S to save. Now I like to show you what is going. If we play with some parameters we have right now, we have the compression and the compression compensation. This one is useful when you have some explosion. We can talk about it in coming tutorials. So here you see that now we have the possibility to move between peak solver and flip solver. The flip solver is able to create something about more related to large scale fluids, and the peak solver is able to create something about small fluids. So you have a nice parameter that is moving between the peak and the flip, so you have not to decide precisely which one you like to use. So for example, if we go here, let's go to use a smaller value to be faster, and I press, you see that we have a different kind of movement with, you see a smaller details over our fluid. If we go up to 100%, we are going to use finally completely flip fluid. So you see that we have some small details that are going to break the surface. Okay, so you can play with this one to find the best compromise. The fault is 95. It is a little bit of peak and a lot of flip, and it can be enough for our test. But obviously, if you see that you like to create something different, you can do it. Let's add a little bit of stickiness. Stickiness is useful to make the fluid sticking over the surface, so it will try to stick over the surface, and it's interesting how it will behave. Obviously, the fluid seems behaving in a different way because the scale is smaller, you know. What about the surface tension and the density? Finally, we have this kind of parameters, and that's really nice. We can have the surface tension, so you can go really lower, but you can go also really high. So let's think about the really high parameters. So you're going to have a lot of tension over the surface, and it will be nice to have something like that. But obviously we can try to go back to a smaller scale to see what's going on. So apply and press space to see the simulation. So it will behave in a different way than before because there is a lot of tension over the surface, and it is going to create some kind of nice effects. It is based on the scale of the simulation, so you have to find the best compromise for your test. Okay, so when we have the final parameters, we can try to see if we like to have it in this way, or maybe we like to have it in a different way. You can see how it is behaving right now, and you see that here we have also the density. So we can go, for example, to a really low density fluid, and the behaving will be different than before. Also, this parameter is useful based on the scale, because you know, obviously we are working on a sphere that is 2 meters and a half. So if you are trying to simulate something that is really, really big, you can use a larger scale models, or you can tweak the parameters to work in the way you like, simulating a different scale. Okay, so we'll see in a few if this value is okay, or we like to simulate in a different way. Stop, Control S. Let's talk about, let's introduce the Whitewater. We can create the Whitewater. It's really, really simple. It is able to simulate bubbles, spray, and foam. You see that now we have the Whitewater. We need an emitter, and we have the Whitewater emitter for the moment, but we need to say where the Whitewater will be emit. So we need a shape, and this shape acts as a container. So we can, for example, create a box and say, okay, 10 meters, 10 meters, 10 meters. It is here. We can move it there, and maybe say 20 meters, 20 meters, 20 meters. So we are sure that we are creating the Whitewater. Apply and reset, and we should start to see something. To To see just the Whitewater, you see that here we have liquid mesh over the view and Whitewater. Let's remove the white mesh and we should start to see something, but obviously it depends on the stuff we set. You see that here actually it's saying that we have 14,000 particles about the Whitewater, so it's not so much. Now it is generating more stuff. You see that we see maybe the bubbles here, but I can see still the foam, and it depends on obviously the parameters you are going to use in your simulation. Now we are starting to see something in the particle count, but it is still not so much. Okay, there is the possibility to see some parameters over the surface here, because if we see here in the Whitewater emitter, you see that we have some parameters about the emission, so we are able to see how the mesh is behaving. We have the trapped Whitewater, you see the coloring, and we have the wake press. Okay, let's say that we go lower with the white crest and we go lower with the trapped. Okay, and let's say stop here, and let's say that we are going to create maybe 10,000 particles by seconds for both, and actually it is creating everything. So it is creating the spray, the foam, and the bubbles. Okay, let's go back to the standard visualization, reset, and play. You see that it is starting to create more particles than before, because we asked it to create more particles. And you see that now we have some white stuff over the surface. It needs obviously to be tweaked because it is too much based on what we are trying to achieve, but now it is starting to work. So you see that we have a lot of stuff that are created. Okay, we have the bubbles rising up, we have the foam, we have the spray, so we have everything. Okay, we have just to take care about it and tweak the parameters to make it working in a better way. So let's stop and save. So let's continue checking what we have. Actually, we can have back the ground, but we are going to have a uniform color, so we have this kind of the ground over here to have something that is nice. Now we can play a little bit with the foam, and then we go to play with the also, because you see we have spray, we have everything, so we have to tweak the parameters, and then we go to have a nice scaling for the effects. So we can start playing with the Whitewater. We can have more particles because actually we are using a low amount. You see just the 3%, but we are going for sure to use more particles. So let's say that the maximum number is 50 millions. We are going to simulate spray, foam, and bubbles. Here it is matching the ISO value for the surface. That's okay. It is using the same force on the spray we are using on the surface, and that's okay. So for the moment we can stay with the default value, but I'd like to show you something that can be changed, and it's related to the scale. Okay, so let's stop in this way. You see that that's the radius for the spray, so it is really big, and I like to have a really small scale. So let's go for 0.75 for example, and here we have the foam component, and we say the same 0.75. Obviously you can tweak as you prefer, it is up to you. And here we have the bubbles. The bubbles are inside, So you see here we have the bubbles. Obviously we have no refraction for the bubbles, but maybe we can do something in rendering when we are outside of LiquidGen. Then something that needs to be done is also related on how the Whitewater is created. Here you see that we have some parameters. We have the trapped air and the way we have the wave crest, the lifetime, and stuff like that. So for the moment, I like to here you see that we have the possibility to see the trapped air and the wave crest. I have to say that sometimes it doesn't work. I think it's related to the alpha. So sometimes it's visible and sometimes it's not visible. Sometimes it's changed completely color. By the way, we are going maybe a little bit lower, higher here. Let's say 0.05, and we go lower just a little bit to 0.5 for the crest. We have 10,000 particles for the trapped air, and we have 10,000 particles for the wave crest. That's okay. So you see that the particles are visible and are nicer, obviously. We can try to see what's going on when we have an higher quality for the simulation. So let's try for 0.2 for the moment. So we need more particles. So let's go here in the particles and let's say 32 millions. It should be okay. Okay. And let's see what's going on in the simulation. So essentially at the beginning it is not so interesting because we are not using the initial part, but then we are going to use and to see how it looks when we are creating the surface. You see that here we are starting to create the vortex, and then we have the noise all over the surface. Let's see without the cloud mesh. You see that we are starting to generate spray and foam. So let's step back. Okay, it is starting to be generated. So let's see without the trapped material, and we can go in the appearance and have an higher absorption and see what's going on. It is really not bad. I mean, and we have still not the final quality because we are still using just 64% of the particles, so that's not completely the final quality. And just to give you an idea, when you are going to render, actually in LiquiGen we have the possibility to use the photo mapping, but it is not so fast on my GPU, but it works nicely. And we have a new rasterizer, this one. The rasterizer has the number of samples, so if you are going to use more samples, let's say for example 8, you see that the quality is higher than before. 16, 10, sorry, it is really nice about the quality. So we are creating something that is really, really nice. So here we have the false value we had at the beginning about, I will show you in a few. So let's we need more voxel because we are using 100%, so we need more. Let's see with 32 millions. Okay, but we need more particles, so let's say that the maximum amount of particles is 64 millions, so it should work. We are using near the 100% for the particles and the voxel. Maybe we need a little bit more voxel because we have waves and stuff like that, so we can try. Okay, Control S, and then let's try to simulate. Now this one will be more advanced because we have a better quality. You see the iteration as always really low, so we have not to take care about it because we don't need so much. So let's leave the simulation and let's see if we have something more to talk about. Maybe we can do something about the meshing. It is up to you, because usually with a lower value of the ISO value, we have more details over the surface, but you know, you can lose some smoothing. So let's see. Let's wait for some frames. By the way, the test we posted was done using an ISO value to 0. So mesh is really maybe more detailed. So details are more visible when we have the waves. But on the other side, we have less smoothing at the beginning and less smoothing over the surface. So it is up to you to decide which is the best way to see it. Okay, so you have to think about which kind of effects you like to obtain. So it takes a little bit of time, because obviously now the surface has a lot of details, and this one is a little bit different than the test we posted, because it is going to use different value for the simulation here about the density and the surface tension. In the test you saw over our social network and the test we posted on YouTube, the animated one, we are using the full value for the density and the full value for the surface tension. So it's a little bit different, you know. I like to see how it is going with Whitewater. So let's say that we have no, in the simulation liquid appearance, we have some crash here. That's not so nice, because we reached the maximum number of triangles, so we need more triangles for our mesh. And about the simulation here, we can say that we don't need the refractive, and we go darker with our mesh, so it will be more visible if we have the Whitewater. And we have the Whitewater, maybe we need a little bit higher scale, but it depends. So let's go back to liquid and reset and simulate the game. We are using one substeps. Obviously, if you like to have something more precise, you can go to 2 substeps. It will be a little bit slower, but you will see more details in the simulation. Okay, so let's wait to have a little bit more details. So we prepared some frames about the simulation. You see that here we have a lot of details that are coming up, but I like to see if we have enough Whitewater. We had 005, 005, that's okay. We have enough amount here. Let's see in rendering if we can tweak a little bit to have a little bit more visibility about the foam. And let's see the spray. Okay, the spray needs to be not so much big, so maybe something like that. And let's go to check the ground if we can have a darker color, something like that. Okay, so we have the reflection. It is really roughness. We can have more roughness, so it will be a really nice background. And then back in the liquid appearance, we have a nice absorption here, and let's see if we can have something like that. Now we go to something like that to the albedo. It is starting to work, you know, so we have some kind of nice effects over the spray and stuff like that. So if you like to have more, you can go here in the Whitewater and say, for example, that you like to have, for example, 0.25 and 0.6 maximum and 0.4 just a little bit more and 0.7 here. And about the dragging, I like to add a little bit of dragging to the foam. Let's say that we have maybe 5 about the dragging, so the foam is dragged over the surface. Okay, so let's go back and let's see what's going on, and Control S to save. Okay, so we have a new simulation. You see that we have more foam generated over the surface. In this case, maybe you can go back to the scaling we had before, but again, it is up to you about which kind of effects you are trying to achieve. Same for the foam. I mean, we can use, for example, one here, and if needed, you see that we have more space for the Whitewater, so you can think about to have something like, we say, okay, we can go maximum to 30 million particles, and you can say, okay, let's generate 20,000 particles for Troubleshooting and wave crest. And then about the simulation, first of all, let's say you can do two things. One is using this one as we done, and the other one is to use the default parameters, so lower value. So just to let you know, I like to show you a frame around 300 and 320 here, and then we see the same with the different setup. Okay, so let's try to simulate. Okay, so you see that we have a lot of details, so it is working nicely. We have the spray here, we have the trapped water and stuff like that. Obviously, again, now we have more particles, so you can always decide to go here and say, okay, let's use, for example, 0.75 for the foam, so you see they are smaller. Again, it is up to you how you like to use this one, and the same for the spray, etc., etc. So you know how to manipulate. So that's what we can achieve, obviously, with more details when it is moving and stuff like that. And it is what we are going to save. Okay. By the way, you can use also the default value, and the default value are essentially, we can, I think we can directly go creating something here, like if we go to create no, we can directly go to peak, so let's go to save. We go here, we can directly open the one I prepared to render stuff, so let's stop. And here the default value are essentially around 972, so let's say this one can be copied, so, and the other one is 72. If we go here and we set the same, so let's say 72, and here we go to set the one we pick it here, we can try to create the new simulation, see what's going on with a different value. By the way, I just saved the previous one, so we have the right one for our new test. Okay, it's done. You see that maybe in this way we are achieving a more splashy effects, because obviously we have less tension over the surface, so we are going to generate more details and more splashy effects, so maybe it seems a larger scale simulation. So it is up to you. So you have to decide which kind of effects you are trying to achieve, and in this way you will be able to decide which is the parameters that you like to use. By the way, maybe I can save also this one, so if you need it you can use it. So let's call it B, so we have both. So thanks for watching, guys, and we are going to release more stuff related to LiquidGen in coming weeks. Next week we are going to talk about how to export everything to Unreal, for example, and maybe also to other software, and then we'll move forward with something else. Bye.